A little bit of a different video today. Obviously don't have a screen share to set up here. It's better lighting though. There's a guy in a Crown Victoria watching me, which might be an old cop car. It looked like he was passed out though. Now he woke up. I was inspired to make this video when I saw this meme. No, not that one. This meme. And the reason why I was inspired to make a video is because there's a lot of truth to it. You don't need programming. Well, maybe you do. Many people are trying to decide what skills to add to their talent stack. If you know what you would do with knowledge of how to program in, say, Python or another programming language, I don't want to discourage you from doing that. Again, if you know what you want to do with those skills. But if you're just generally looking to become, say, more efficient, more effective at work, and you just want to get better at things, you just want to be able to manage a business, better manage your job, better manage employees, do quick analyses, Excel is more than enough for you to be able to do all those things if you pair it with this skill that we're going to talk about today. That skill is the skill of solving the right problems. Welcome to Excel Smart. You can be amazingly effective and efficient if you're good at Excel and you know how to solve the right problems. There are two aspects to this skill of solving the right problems. The first aspect is actually one you've probably heard before. See if you can find the common thread between these bits of advice offered by people much more famous than me.
Habit number 2 of Stephen Covey's best-selling book, The 7 Habits of Highly Effective People, which is to begin with the end in mind.
One of my favorites that I love to solve these kind of chess puzzles is called retrograde analysis.
DMAIC is the acronym for Define, Measure, Analyze, Improve, and Control.
That you used to go up on Mulholland Drive and park
every night
and visualize seeing yourself as...
Yeah, I would visualize having directors interested in me. And
customer obsession is not just listening to customers. Customer obsession is also inventing on their behalf.
If I'd listened to what people wanted, I would have made a faster horse, is one of the most famous Henry Ford quotes.
What you just listened to is different versions of the same advice. Before you start a problem, you need to understand what the true need is of the problem you're trying to solve. I'm going to use some examples from my life to explain what that is. I have an employee, let's say his name is...
Sweet dreams, Chris.
Chris was asked by an important person, let's say...
So what do you think, Barry?
I haven't read it.
Barry emailed Chris. He said, "Hey Chris, I noticed our inventory dropped quite a bit. Did we ship a lot of high-value assemblies yesterday?" And Chris wanted to solve this problem for Barry. So what did Chris do? Well, Chris looked into high-value shipments for the previous day and he found there were no high-value shipments. So he responded, "Hi Barry, we did not ship more high-value assemblies than usual yesterday. Thanks, Chris." Now, Chris made the mistake of not solving the right problem here. Chris did not identify Barry's true need. So what is Barry's true need here? Well, let's take a look at Barry's email again. "I noticed inventory dropped quite a bit. Did we ship a lot of high-value assemblies yesterday?" The direct question was, did we ship high-value assemblies? The reason why Barry's even asking this question is because inventory dropped. So Barry wants to understand why inventory dropped. He simply proposed a potential answer to that question. The easiest way that Chris could have identified true need is to anticipate the next question. Imagine how this email exchange might have played out. Barry, inventory dropped. Did we ship high-value assemblies yesterday? Chris, we did not ship high-value assemblies yesterday. Barry, why did inventory drop? Chris, oh, our report is a day late and our inventory actually dropped the day before. Barry, well, why did inventory drop the day before? Chris, a lot of our inventory was scrapped. If Chris is going to answer only the immediate question, he might be pulling data out of the inventory system repeatedly. First, he has to pull high-value shipments. And then when that doesn't answer the question, he has to pull high-value shipments for a day in advance. And maybe he has to pull receipts again. And he's doing multiple data pulls here, which would be better with heavy automation that programming might allow you to do. But you don't need to use the programming if you answer Barry's true need. One data pull, you can use Excel to summarize what's going on and answer what's going on with inventory. Because you're solving the right problem, you don't need the programming. In fact, there's another level to this. Why is Barry even concerned with inventory? In general, Barry wants to know that inventory is under control and whether or not we are going to hit the inventory plan. So what Chris can do in this response is give Barry the comfort that inventory is under control. For example, Chris might say, "Hey Barry, we did not ship a lot of high-value assemblies yesterday. Our inventory actually dropped because we scrapped a lot of inventory 2 days ago. We have alert systems in place so that we know when inventory changes by a sufficient amount. Would you like to be included on those communications and alerts? Thanks, Chris." Barry may want to sign up for alerts, or he may simply be content knowing that Chris has a handle on the inventory and he doesn't have to worry about it. That anything surprising that's going to happen to inventory, he can either knows that Chris will be the go-to contact for, or maybe there are reports so Barry doesn't even know to go to Chris at all. I'll give another example. I'm a part of a Toastmasters chapter. Toastmasters is a public speaking club. One of the fellow officers of this club had a problem where for a better part of a year she was trying to set up a mentorship program. Our officer, we'll call her Kate. Kate was working on this mentorship program for a better part of a year and wasn't having a lot of success. Setting up a mentorship program, especially in a voluntary organization like Toastmasters, isn't exactly easy. Eventually, we discussed the problem amongst all the officers and asked Kate, why is it that you're trying to set up this mentorship program? She was trying to help improve our membership numbers, and she had heard from someone high up at Toastmasters International say that the best way to improve membership is through a mentoring program. Kate was putting all this effort into building out a mentoring program to solve a membership problem. Kate didn't really need to make a mentoring program. That was just one way of solving the bigger problem of improving membership. Another way you can identify your customer's true need is by asking why. If you need to increase membership in a club, a mentoring program is just one way to solve that problem. There may be other ways to solve that problem. You can have better advertising, member feedback surveys. There are a number of ways that you could do this, and you can actually use Microsoft Excel to solve that problem by analyzing, say, a membership funnel. If you're trying to build out a mentoring program, you might need a skill like programming so that you can deal with automatic emails, make sure people have a certain amount of meetings set up to speak with their mentors or mentees, etc. It's a problem that you can use programming to solve. But you don't need to solve this program with programming because the true need is a simpler one. All right, the first aspect of solving the right problem is understanding your customer's true need. So what's the second aspect of solving the right problems? Well, I have another compilation. This is advice you may have heard before, but see if you can find the common thread here.
Object-oriented programming is a programming language model for software design that revolves around objects or data instead of logic and functions. In other words, it focuses on what developers want to manipulate rather than how they want to manipulate them.
The actual steps that comprise 5S are sort, set in order, shine, standardize, sustain.
The front end is the part of the app the user will see. It is nicely designed and easy to interact with. The back end is where all of the data is stored and requests are processed, like a warehouse or a storeroom.
And not the jargon, system or systems thinking, but the reality that we live in webs of interdependence.
Now we will move on to what is database. A database is a systematic collection of data. They support electronic storage and manipulation of data. Databases make data management easy.
The second aspect to solving the right problems is organizing your objects. And that means organizing the building blocks to which you will solve the problem with. I'm going to use Chris's example again. If Chris is going to answer the question of what happened to inventory over a given period of time, Chris needs to look at not just shipments, for example. He needs to look at anything that has a potential impact on inventory. And for those of you that have worked with inventory in any way, you might know what these are. So you have receipts, you have inventory depreciation, you have financial reserves or contra inventory accounts. To be able to answer a question on inventory, you need to know what these pieces are. These are the building blocks for your solution. Chris only pulls shipment data. He's at high risk of getting the wrong answer. This idea of approaching things as objects is actually critical to a lot of programming languages, but it's a concept that can be applied to how you use Microsoft Excel. Often in Introduction to Databases courses, you'll be asked to do something like build a simple database for, say, a school. And this is a great example of how to organize the objects you're solving problems with. In a school, you have different things. You have students in a school. You have teachers. You have classrooms. Maybe you have different buildings. You have subjects. You have days and years and time slots. You have a lot of different information that are all different things, so to speak. And the way you set up your database is you have each thing organized in their own tables. So that's really what a database is. It's a series of tables. Instead of, say, having a class of being its own thing where you have, say, 15 students and a teacher, what you have is all those individual objects tied together. It's a series of relationships. When you have a database set up like that, easy to stay organized and query the database for, say, like, give me what this class looks like, or if I make this change here, what conflicts am I creating? Where else do I have to move, say, students around to make sure all my classes stay under a certain number of students? You can do things like that if you have your objects organized. People make the mistake often of when they try to pull information or use data to solve problems of filtering data before they start solving the problem. Pulling only shipments to solve an inventory problem would be an example of this. It's easy to assume that dealing with more data makes solving the problem more complex. But the reality is, most of the time, the larger data set is worth it.
Because I'm worth it.
Because it will simplify the problem solving. It's more data to deal with, but having to solve the problem again and again and continually add in new data because you're missing some data is much more complicated than simply starting with more information. The way I like to diagram this, and I'm going to do this, I'm not going to do it with my hands necessarily. A lot of people will see the chart where you're talking about it compares information to knowledge to wisdom. I think this is a good chart to represent how to solve the right problem. Understanding your customer's true need is effectively a finish line or a node that you're trying to get to. And then understanding your starting point and then organizing your objects is a matter of knowing which nodes you're starting from, which are going to be more towards either a start line. If you set your problem up correctly, you can make an easy path and know how everything has to come together. If you fail to identify the true need, or you don't have your objects well organized, you could find yourself going back and forth and doing extra work. How does Microsoft Excel come into play? Well, Microsoft Excel is effectively its own programming language in a way, but it's simpler. You can see everything that's going on when you work in Microsoft Excel. And unlike programs like Python and R, most people, almost everybody in fact, has Excel or something very similar installed on their computer. My undergrad degree was in mechanical engineering. When I was in college, we used advanced software packages even at the time. So things like MATLAB, ANSYS, SolidWorks. And then when you get into the professional world, what does everyone use instead? Microsoft Excel. Because everyone has Excel. Depending on your job, most of the people you work with probably aren't going to have the exact same education that you have. So there are downsides to being reliant on advanced software packages. Excel can also assist with both aspects of solving the right problem. Excel has a lot of data manipulation and organization features that can help you set up and organize your objects. For example, Excel can handle a decent amount of data, about 1 million records per sheet, for example. By having multiple sheets in an Excel workbook, you can have effectively the multiple tables you might have had in a database. You can use text manipulation functions like concatenate or text to columns or remove duplicates to organize your objects the way you need to. For one example of this, I have a tutorial that heavily goes into the organizational functions of Excel linked on screen. Then once you have your information organized, you are well set up to now query that data using lookup functions or pivot tables. That aspect of Microsoft Excel is the analysis portion, and that will help you go from your organized objects to the true need of your customer. In fact, you can create dashboards and front ends for people using functions like conditional formatting. If you want a tutorial that dives more into those aspects of Microsoft Excel, check the link on screen for a tutorial that does a lot of that. I have one more example that I have to mention where solving the right problem can save you time and avoid the needs for heavy programming skills. I used to work in an department where every time we wanted to order new hardware, someone that was planning the builds would have to fill out an electronic form to create a requisition that would go over to the purchasing department. And this form took a long time to fill out. So someone brought up the issue to people that knew how to automate to say, hey, we need automation help to be able to fill out a lot of these forms quickly. We could have done that. The true need was not filling out the form. The true need was triaging purchase requisitions. It turns out that there was a field that could be checked in our ERP system to identify a firm requisition. Sometimes the best way to automate a process is to make it so that process isn't even needed in the first place. If you want to be successful in your career, if you identify the right problems, Microsoft Excel is more than powerful enough to take you the rest of the way there. So if you enjoyed this video, let me know if you'd like more content like this to go along with the Excel tutorials, and I'll see you in the next one. What's the best way to make sure your car will pass inspection? It's to not even need a car in the first place and just walk everywhere. Oh yeah, now he's driving away. Was he taking a nap or something?